Hi everyone, welcome back. As you all know me, this is Pavitra, pursuing third semester in the Department of Computer Science and Engineering at Sri Venkateswara College of Engineering, Bangalore. And in today's video, I'll be discussing about principles of experimentation in design. Introduction to experimentation principles. Experimentation is crucial for validating design hypotheses and theories. Understanding the principles helps in formulating effective experiments. This presentation covers key principles that guide effective experimentation. Clear objectives. Clear objectives guide the direction of the experiment. They help in formulating specific research questions to be answered. Well defined objectives ensure that the results are relevant and actionable. Importance of experimental design. A well structured experimental design minimizes errors and biases. It ensures that the results obtained are reliable and valid. Good design facilitates and the comparison of different experimental conditions. Experimental design involves the careful manipulation of an independent variable while controlling and measuring other variables to assess their impact on the dependent variable. It is considered better than observational design when it comes to inferring cause and effect. And there are two types: quasi experimental design and true experimental design. Quasi includes some control over variable but falls short of the random assignment of participant to conditions. True experimental design incorporates random assignment of participant to different conditions, allowing for stronger causal inferences to be made. Hypothesis formulation. A clear and testable hypothesis is fundamental to experimentation. Hypotheses guide the direction and focus on the of the experimental study. It helps in predicting outcomes and understanding relationships between variables. Formulate hypothesis. Hypotheses provide a basis for testing and experimentation. There should be specific, measurable, and testable statements. A strong hypothesis sets the stage for meaningful analysis and conclusion. A clear and testable hypothesis is fundamental to experimentation. Hypotheses guide the direction and focus of the experimental study. It helps in predicting outcomes and understanding relationships between variables. A hypothesis is a tentative statement or explanation that pros- pros- proposes a possible relationship between variables and is subjected to testing and verification. And there are two examples: null hypothesis and alternative hypothesis. Null hypothesis is a statement that suggests to significant relationship or effect between variables, and then alternative hypothesis is a statement that proposes a specific relationship or effect between variables, challenging the null hypothesis. Control groups and variables. Control groups are essential for establishing a baseline for comparison. Identifying independent and dependent variables is crucial for analysis. Controlling extraneous variables helps in reducing variability in results. And variable is a quantity that may vary. It is widely used within the context of a mathematical problem or scientific experiment. Normally, we use a single letter to represent a variable. The letters X, Y, and Z are common generic symbols used for variables, and there are two types: independent variable and dependent variable. Independent variable are not affected by another variable, and these represent the input values for a function. These are commonly denoted as x, and they are sometimes called the argument for the function. And dependent variables are influenced by another variable. Dependent variables represent the output value for a function and are commonly denoted as y. They are sometimes called the value of a function. Randomization. It helps eliminate bias in the selection of subjects or samples. It ensures that each participant has an equal opportunity to be assigned to any group. This principle enhances the generalizability of the results to a broader population. Replication. Replication is vital for confirming the reliability of experimental results. It allows for the verification of findings through repeated trials. High replication strengthens the evidence supporting the hypothesis. Collect and analyze data. Data collection methods must be systematic and consistent. Statistical analysis is crucial for interpreting experimental results. Proper analysis helps in validating and refuting the initial hypothesis. Sample size determination. An appropriate sample size improves the reliability of the experiment. Larger samples reduce the margin of errors and yield more accurate results. Statistical power analysis can guide the determination of sample size. Data collection methods. Selecting appropriate data collection methods is crucial for accuracy. Methods can include surveys, experiments, or observational techniques. Proper data collection enhances the quality and integrity of the results. Statistical analysis. It is used to interpret the results of the experiment. It helps in determining the significance of the findings. Understanding statistical concepts is essential for drawing valid conclusions. Reflect on the process. Reflection on the experimental process identifies strengths and weaknesses. It encourages continuous improvement in experimental design and methodology. Sharing insights from the reflection can benefit the wider research community. Conclusion. Adhering to the principle of experimentation enhance design reliability. Continuous learning and adaptation of methods lead to better experimentation. Implementing these principles fosters innovation and improvement in design processes.